Okay, so right now we're looking at the relationship between mass, moles, and number of particles, and we'll learn how to convert between mass, moles, and number of particles. We learned about the definition of a mole, and the definition of a mole is that a mole contains 6.02 times 10 to the 23rd particles per each mole. So if you knew the number of moles and wanted to convert into the number of particles, you could just multiply by 6.02 times 10 to the 23rd particles per every mole, and you'd get the number of particles. If you had the number of particles and you wanted to go back into finding out how many moles you have, you'd use 1 mole over 6.02 times 10 to the 23rd particles. The number of particles would cancel out, and you get the number of moles. To go from moles to mass, you're going to use the molar mass. So the molar mass can be found on the periodic table, and it's the mass number you found on the periodic table in grams per mole is the molar mass. It's how much 1 mole of the substance would weigh. If you want to do a conversion from mass to number of particles, you need to do it in 2 steps. You need to first convert into number of moles, and then convert from moles into number of particles. So we'll look at a couple examples and see how this is done. So our first example says, what's the mass of 3.9 times 10 to the 22nd atoms of copper? So we're given the number of particles, and we're asked to find out what its mass is. So we're given number of particles. It's going to be a 2-step problem where we first find out how many moles we have, and then take that number of moles and find out what the mass is. So we start out with 3.9 times 10 to the 22nd atoms of copper, and we want to convert that into moles. So to go from number of particles, in this case atoms, to moles, we're going to use Avogadro's number. So we'll put 6.02 times 10 to the 23rd atoms on the bottom, and then on the top we'll put 1 mole of copper. So atoms of copper can cancel out, and then we get moles of copper. Problem's going to take one more step, and that is that the question is asking us what's the mass. It didn't ask us for a number of moles. We need to take a second step. And so for the second step, we need to use the molar mass of copper. So I'll look at my periodic table. I'll find copper on the periodic table. Its molar mass, 63.55. So 63.55 grams of copper. It's going to be different for each element, but in this case we're working with copper. And that's for every 1 mole of copper. We have it set up correctly so that moles of copper can cancel out, and then in the end our units will be grams of copper. So we do this on our calculators, and we get 4.11 grams of copper. So this was a conversion where we were given the number of particles, we used Avogadro's number to get the number of moles, and then we used molar mass from the periodic table to get the mass. Let's do one more example. This one's a little bit different. This one, we're going to be working with NO2, which is a molecule rather than just a single element. And this time we're given the mass and asked to figure out how many particles or how many molecules that is. So this time we're starting with the mass, and we need to go to moles, and then from moles into number of particles. All right, so starting with 42.5 grams of NO2, we need to take the molar mass of NO2, do grams of NO2 on the bottom, and moles of NO2 on the top. So to find the molar mass of NO2, we look at the periodic table, and we need to find nitrogen and oxygen. So nitrogen's 14, oxygen's 16. We need to add those together. So we have 14 for the nitrogen plus 2 times 16 for the 2 oxygens. And so when you do that, you find out the molar mass is 46 grams per mole. So that means if you have 1 mole of nitrogen dioxide, it would have a mass of 46 grams. So we put the 46 grams right here, 1 mole right there. That way grams of NO2 can cancel out, and you convert it into moles of NO2. Then our second step, we want to get the number of particles, in this case molecules. So 6.02 times 10 to the 23rd molecules of NO2 for every 1 mole of NO2. We have it set up so that moles can cancel out, and then in the end you'll get molecules of NO2. And when we do this on our calculators, we get 5.56 times 10 to the 23rd. And so this was an example where we were given the mass of a substance. We used its molar mass. It was a compound, so we had to add up the molar masses of each element within the compound. That converted us to moles. And then to go from moles to number of particles, we used Avogadro's number. You're always going to use Avogadro's number no matter what the substance is. Molar mass is going to vary depending upon what element it is, and you'll need to use your periodic table to find the molar mass of that element, or if it's a compound, to add together the molar masses of each element within the compound.